we've seen a couple examples of recursion. We're going to look at one more real quick. So just a reminder, when we call a recursive function, we can examine the call stack, and we see that it just builds up and builds up and builds up. So we can also, let's see. Yeah, so the call stack, the way that it works is actually, so let me just go ahead and call this real quick. And I'll set my breakpoints, go to the debugger, run and debug. It's a Python file. And I can step through using this down arrow. We can see that the call stack is now populating. So it doesn't return, so it just builds up and builds up and builds up until we get to our base case, and then it all unwinds. So we start popping things off the top. Okay, so this data structure, so we saw with the parentheses, the balanced parentheses, Encore had to actually use a stack. So he didn't explicitly use something called a stack, but he treated an array like it was a stack. So the rules for a stack are that you can, so remember, a stack is like a stack of plates, right? You can only put things on the top, and you can only take things off of the top. So there's only one point of entry and exit for everything, which means that the order you put things on is the reverse of the order you take things off. So I put on 1, 2, 3, and I take off 3, 2, 1. So that's how a stack works. We can actually implement our own. So now that we're familiar with object orientation in Python, we can actually implement our own stack. So we'll go ahead and do that. We'll create a stack class. Class stack. And we've got def in it, right? So we'll just do this, and we'll do self. And for now, we'll do path, because we're not sure what's going to be in there. And stack has a couple, it's weird. So yeah, sorry. So stack has a couple required methods. So there are some, but the core are pop and push. So we need to be able to put something on to the top. So that's called pushing, and take something off of the top, which is pop. So there's two methods that we're going to need to implement. So def push, and we'll do pop. So what we're going to be doing basically is creating a more specialized array. So we're going to use an array as our base data type. We could use a string or something else, but I think this just makes the most sense. So we'll do self dot data store is an array. Okay. And then when we want, so nothing outside of this object should be able to directly, again, we don't have private methods and properties with Python, but we don't want anything outside of this to directly interact with this. So we could indicate that informally. Oops, not so, but you can indicate that, informally in Python by prefacing your method or piece of data with an underscore. So you can either do that or not do that. It's up to you. So push, what we're going to do is add something onto the end of this array. So the way we do that, pretty easy. We should know that in Python. So we'll do self dot data store dot append. So that will put something onto the array, and then whatever it is that we pass in. So we need to add a second parameter to push. So we'll do, actually, we're doing call stack. So we'll do, we're going to add a function, actually. Okay, and now we have a push method. So we're going to we're going to create a stack and we can push something on. Now we need to be able to take something off. So we'll add a pop method and we'll return self dot data store dot pop. So we can use the built-in method here. So the thing about stack is you might think, okay, why are we we're creating a method that does the exact same thing as the Python built-in method. But if we create our own class, it actually allows us to customize behavior. So this is the only thing that this class can do. It only has these methods. You can't do insert or anything else that you can normally do with other arrays. So if we want to create an instance of this stack, we do just like we do for every other class. So stack. And then I can try appending some stuff on here. So I'll go ahead and append a couple things. So s.push. I'll put hi for now. s.push there. Okay, so I want to push some stuff on. And then I shouldn't do this, but I'll go ahead and inspect the actual data store. So s print s dot underscore data store. We should see that there are 3 things on this array. CD. It's call stack. Okay, so we see that we have 3 things, hi, there, bye. And if we want to now pop something off, we'll do s.pop. And we'll check our data store again. Okay, so hi there, bye, it pops off bye and returns it. And then we just get hi there. So notice that we put hi on first, but it's going to be the last one to get popped off if we keep popping things off. Okay, so this is a stack, right? So when we were using the debugger and we saw the stack building up, this is, basically what it is. It's just a kind of data structure. So we can actually use this to model our own implementation of a stack. But before we do that, we're going to look real quickly at a nice, there's something in the README that links Python tutor. We'll go to Python tutor and we can write some, we'll write some code here. We'll use this. And then we paste it in and we run it. It's basically just like a nice debugger, and we can see the stacks. So we'll start here. So here's our function. It's just a recursive function that we threw in there. And over here on the right, we can see our frame. So this is the global frame. So this is basically the entry point for your application. This is, in JavaScript, this would be like the window object or something like that. And now we're actually calling our function. So here's the stack. So it starts on the global frame and then count up gets added to the stack. And it steps through, we can keep going. We call it again. So now another count up function gets added to the stack. And you can see that it's keeping local variables here. We can keep going. Right, so that's just going to keep building up and building up and building up. And eventually it's going to all unwind. Everything's going to start popping off. So we see it popping off, popping off, popping off, popping off. Okay, so we have a stack, right? So the first thing to get put on is the last thing to get popped off. And we have this execution context, right? Which is the function call with some stuff in it. So we can go ahead and we can use object orientation. So we can build we can kind of model, we can model this. So let's write a function which will create a call stack. So we'll do this very simply. So create stack, something like that, and we'll do, this is called frame. We'll call it a frame. We'll just make it an object. I'm also going to create, I'm just going to use a random number to create a local variable. So import random. I'm going to call equals random.randint. This will give me a random number and between 1 and 100. Okay. So my frame, remember, it's going to keep track of the function, a function name, and the local variables and stuff. So we'll do function, and we could actually write like a lambda function or something, but I'm not going to do that. We're just going to keep it simple. So we would actually be able to call a function that we wrote here. But again, so this is just this. So this is going to model. Let's see.
Your colon is
Oh, right. Sorry. Thank you. Okay. So we'll return the frame. And then let's go ahead and we will, let's start popping some stuff, or sorry, pushing some stuff onto the stack. So we'll do s equals stack. So we've got our stack and we'll push some stuff, s dot push, and we'll do create stack. We'll just copy that. So this will be like a recursive function call. So we got 3 things on the stack now. And we can do we'll do print s dot, again, shouldn't do this, but data store, we shouldn't be able to access. So ideally, we would write another method here in this class that would give us access to data store. Actually, I'll go ahead and do that right now, just for the sake of propriety. So we'll do def get store data store. So we'll do something like that. So let's see what we get here. And I'm going to use pretty print actually. So I'm going to import pretty print. And I can use, so there's a pretty print method on the pretty print module. So now we can see that this is a function, local var. Actually, I'm going to go ahead and pass in another. Let's do, just so you know what order things are happening in. Okay, and we will do okay, so if we run this, we can see that again, just like a stack, just like we saw here, where the first one to get called is the last one to get popped off. So here it's basically reverse order, right? So this function gets called first, but it's going to be the last one to get popped off. And this function gets second and third. So we can pop them off and we'll see what happens. We'll do s dot pop, and we'll go ahead and pretty print that. And then we will look at the whole thing again. Okay. So we printed this. This is the first call. And then we popped this one off and we return it. Notice that the first one we take off is the third one that we put on. So the most recent one that we put on is the first one we take off. And now we have left on the stack the second one and the first one. So that's basically how, and we can pop all of them off until there's nothing. But so that's basically what a stack is, and that's kind of what your call stack is doing. So when it runs a line, it kind of creates an object that has whatever values it needs and the function. And then if you have a recursive call, the stack is going to build up and it's going to create a bunch of these objects. And then when you pop them off, it will actually run. It can run the function again. We could have written an actual function here that it would run, and it could use the parameters, like parameters, for example, that we get here, and it could run the function with those parameters. That would have been saved from its execution context. All right, so that's basically all I have to say about stacks. Are there any questions about recursion or stacks?